Okay, in this video, let's take a look at this sequence. And first of all, we're going to find an explicit formula for this. Well, let's write down an. This right here is actually not that bad because we see that we have sine 1, and then here we have 2 sine of 1 over 2, and then this one is 3 sine of 1 over 3. And the next one, of course, you see that 4 and 4 right here. Therefore, once we get to the nth term, we have n times sine of 1 over n. That's it. And of course, let's close the parentheses. Here is the formula. Now, we're going to see if an is increasing or decreasing or maybe neither. But this right here, it's actually pretty hard to deal with if you use the an plus 1 if you want to show that compared to like an, because we have the sign right here, right? So, how else you can do it is just use the graph for it. Well, to do that, let me just put this down right here for you guys. We are going to graph the function version of that. It's easier to do it on your calculator this way. So let's take a look at the graph of f of x being x times sine of 1 over x. And whatever you can say about the function right here, like if it's increasing or if it's decreasing, you can say the same thing right here. And because you will see the picture will actually help us out. Well, when you graph this, you're going to get something really crazy here. Okay, so just kind of graph it on your own, and then it's going to get like this. So it's going to be behaving nicely after a certain point. And the graph of an is just that you are just going to put in when n is equal to 1, 2, 3, and so on. Based on the graph, you'll see you have this point here, and this point here, and so on. In fact, this right here is increasing, but we do see this right here has a horizontal asymptote. Therefore, it does have a limit. Therefore, an does converge. But the second question right here is just that if an is increasing or not. And in this case, I'll say an is increasing. Why? By looking at the graph. And of course, you have to provide the graph, right? And for the third one, we are going to see if an converges or not. Of course, we can use the graph, but let me show you guys how we can do it. Well, not algebraically, just do it by doing some actual computations. Anyway, we are going to check the limit as n goes to infinity of an. And of course, this right here is the limit as n goes to infinity. An is that n times sine of 1 over n. Notice this right here is an infinity times 0 situation. So we cannot draw any conclusion yet. What we can do is just bring this n down, and we are going to get the limit as n goes to infinity of sine of 1 over n divided by, once you bring this down, we will have 1 over n like this. And notice, this and that are the same. That's good. Because when n goes to infinity, this and that, of course, they both approach 0. So we can quote the limit for this right here. And to do so, this is what I would prefer you guys to do. You are going to write this down. You are going to say, like do a substitution, let theta equal to 1 over n. And check this out. When n was going toward infinity, well, theta will now go to 0 because 1 over infinity is 0. So I'll just say theta goes to 0. And of course, the inside is theta here over theta here. And of course, this is not like integral. You don't have the d theta here, okay? So don't worry about that. But anyway, this right here is equal to 1. And if you want to give a little reason, this is by the limit that I discussed with you guys before. Right? This and that input are the same, and then if the input is approaching 0, then we are pretty much done. So I will tell you that an does converge, and it converges to 1 right here. So this right here is very good. That's it.